Diving into one of the coolest and most practical uses of n8n, a powerful automation platform that gives you superpowers when it comes to connecting different apps and services, including managing data and making your workflow smarter and faster. So if you are already using n8n, you probably know how flexible it is. And if you're brand new, don't worry. I'm going to explain everything in a way that is super friendly and easy to understand. So what exactly are we building in this video? We are going to build an automation that listens for a chat message, grab a JSON schema from a GitHub URL, parses it to understand the structure of a database, and then prepare that data for combining with another input like a search query or a question or a user request. And the fantastic thing is that as an output, it gives you a good insight, as well as it will give you a visual diagram, maybe a chart or a bar chart. So let's say you want to find out, you want to find out all your products with category, supplier and stock across different warehouses. So you want to list them, or maybe have a pictorial, maybe a bar chart showing exactly what categories, supplier or stocks are across different warehouses. You want to know the revenue generated per product, or you want to list all pending purchase orders with item details. Okay, so that's where this n8n automation comes into play. Sound cool, right? Before we get started, I've got something awesome for you. You don't need to copy every single code or node that I'm about to show you. No, I put the entire n8n automation workflow into a downloadable file. That means you can just import it directly into your n8n setup and follow along at your own pace. You'll find the link to download it in the description below. Let's break this down step by step and walk through each part of this workflow, how it works and how you can use it in a so first node is when the chat message is received. So let's say you have got a chatbot running. Maybe it's integrated into Slack, Discord, or even a custom web app. You want to trigger a specific action when someone sends a message. That's exactly when this node comes into play. It's called when chat message received. This node acts as the kickoff point. It's just the listening, waiting for someone to say something like show me inventory or can I get my product stock idea. So if you open the open chat here, you can actually type in your query here in a very natural language, and then this whole n8n automation workflow will get into action, and then finally it will give you the data along with some visual graphs, for example a pie chart or a bar chart or whatever you want to have. So this kind of setup is perfect for creating conversational interfaces. Imagine a team member is messaging a bot to ask about stock levels, or maybe a customer is reaching out on your site to find out if that item is available. Instead of manually searching the database or pinging your ops team, this automation takes care for it. So now let's move to the next part of the workflow. After the chat message is received, we send an HTTP request to fetch the structure of the database. This is done through the HTTP request node, and this is the public JSON file hosted on GitHub, and it contains our database schema. As you can see here, it is hosted on GitHub and you can get the URL from the GitHub. So now what is the schema, you might ask? A schema is basically a blueprint of your database. So in our case, we have database hosted on PostgreSQL. Okay, it tells you what tables you have, like products, categories, suppliers and warehouse, and what fields exist inside each of those tables. Things like product name, quantity, price, and so on. Fetching this schema dynamically is a smart move, because if your database base structure ever changes, maybe you add a new table or column, what we call it as schema evolution, you don't need to update your workflow. It always pulls the latest version. Let's say your dev team or a development team adds a warehouse table next week, and if you're pulling your schema from a URL like this, your automation will recognize it without any extra work from you. Pretty neat, right? Okay, so now you have got the schema, but it's just the raw JSON. We need to turn it into something useful that you can pass around in n8n. That's where the parse schema file comes into picture. This node is a JavaScript code node. It's simple but super effective. What it does is it grabs the first item from the previous step, which is in our case is the schema, and makes it available for use in the next part of the workflow. It's like saying, all right, n8n, here is the structure of data we are about to work with. Go ahead and get familiar with it. Now let me pause here and give you a practical use case. Imagine your team is building a new product catalog interface. You want to give them the ability to see the full structure of your inventory database. Just by sending a chat command like get schema, this gives you the entire schema of your database. They message the bot, this workflow gets triggered and the bot replies with the full schema so the developer knows exactly what is available. Again, super handy. Okay, so now let's look at one of my favorite part of this workflow, the combined schema and query node. This is a merge node that is configured in a very specific way. It uses the combine mode with something called multiplex. Multiplexing is like making every possible pairing between two sets of data. So in our case, we have got two inputs, one which is coming from parse schema file and other one is from the chat message, right? Whatever the user enters on the chat window, that's the message comes and gets into as input 1, whereas the parse schema file, what we have parsed in the last node, that comes as an input 2. So if you look at this node, the merge node takes each item from one list, like each table from the schema, and combines it with each item from the other list, like the chat message. So why would we want to do that? Because we can start building intelligent responses. Maybe the user typed show me the product stock levels. By combining that message with the schema, we can now scan through the tables and decide, the table we want is product and maybe warehouse 2. We can now use that to craft the next step, whether it is querying the data, generating a chart, or preparing a report. It's like fusing intent with structure, and that gives your automation the context it needs to make a decision, right? So here is a practical scenario. Let's say your sales manager types, can you show me how much of each product is in the West Coast warehouse? This workflow grabs that message, looks at the schema and figures out, okay, we have got a product table, we have got a warehouse table, let's filter by location and count the units. Okay, then there is a code node. That's where the magic starts. The code node takes two pieces of information, the question you want to ask and the database schema. The code node then creates a prompt for the AI agent. It tells it, hey, here is the user question and here is the schema. Please write a SQL query for me. It even specifies the user fully qualified table names like crm.orders. That helps avoid confusion. If you have multiple schema or tables with similar names, you are trying to specify the schema name. That way there is no confusion and there is absolute clarity. So what does that prompt look like? Something like this. You are a database assistant. The user asks, show me orders over $1,000 last month. Here is the schema. All tables are under the CRM schema. Generate only the SQL query using fully qualified table name. So like that, it generates a prompt for the next node, which is going to be our AI agent. So let's look into the next node, which is the AI agent node. Okay. So in the AI agent node, when you open it, right here, this is the heart of the workflow that calls the AI language model. In this case, we are OpenAI GPT. Okay. So OpenAI GPT in this case generates the SQL query based on the prompt we just created. The agent interacts with the language model. It sends the prompt, okay, and receives the SQL query in response. So what you see on the right hand side is the SQL query. This way we are using AI to translate plain English questions into the real SQL commands, right? So as a user, you don't need to know the SQL structured query language, which is generally the query language by which you interact with the database and try to get information from the database, right? So as a general user, I don't need to now know the structured query language, right? So this AI model basically translates that into pure English questions. Speaking of AI, this setup is super handy because it lets even non-technical people query the databases without needing to learn SQL syntax. Imagine a salesperson or a business analyst just typing their question and getting their data or getting their reports instantly. Database skills are required. Alright, moving on. Once the AI agent generates the SQL query, the next node is execute SQL query. This node connects to your PostgreSQL database. The credentials are here. You need to configure the credentials. Okay. So once you set it up, you should be able to choose it here. And then this node runs the SQL query that the AI generated. Here is an important part. The SQL query is extracted carefully from the AI's output. We are using a little JavaScript trick here to match the first select statement from the AI response, just to be sure that we are executing a valid SQL statement and not any extra text that the OpenAI in this case or AI might have added. After the query runs, we get some results. But what if the query did not run, right? So, or maybe the AI generated something that is not quite right. That's where the check if query or check if query results exist comes into play. Okay, this node is an if condition node, right? It checks if there are any results from the SQL query. If yes, it lets the workflow continue. If no, you could add error handling or maybe return a friendly message saying that no results found or query failed. This condition check is crucial because it keeps your workflow robust and prevents errors from breaking everything. Now you might be wondering, what can we actually do with this setup? Let's think about some real world use cases. Say you run an online stores, right? And you want quick reports on your sales data. Instead of digging into dashboards or writing queries, you could type, give me the total sales by product category last quarter. And the AI will translate that into SQL, execute it, and get you the data. Or if you are in marketing, you might want to know which companies generated the most leads this month. Same process, natural language, AI generated query, and the instant results. What is really cool is that this workflow can be expanded or customized easily. For example, you could connect it to a chatbot interface where users can ask questions in a conversational way and get data back in chat, or integrate it with Slack bot for quick team access to database insights. Also, because it's using n8n, you can chain this workflow with other automation. Like if the sales number exceed a threshold, trigger an email alert or log the results to Google Sheet or a CRM system. Now a quick note about the credential. Your PostgreSQL database credentials are stored securely and in n8n credential manager. You will just need to set up those. You can find the credential manager in the overview if you go here, and if you click on the top right, you can see here create credentials, and whatever credentials that you create, you can see that in this credentials tab. You can see here I have created so many credentials, and one of them is Postgres account and also OpenAI credentials. So you need to set them up, and then the workflow can connect to your database safely. Also, the AI agent node uses your OpenAI API credentials, so make sure you have that configured too. Now we have a node called format data for visualization. This is a little piece of JavaScript code that loops through all the incoming data items. It pulls out labels, in this case the product names, and the corresponding amounts. This is the key because the chart needs a clear set of labels on the x-axis and the numbers on the y-axis. Now here is the cool part. This code does not just take data blindly. It checks if the product name and the amount exist, and it tries to parse amounts into numbers safely. That means if you are missing all or malformed data, it won't break. Instead, it will just skip or default to 0. This makes your workflow more resilient. After gathering the labels and the numbers, it builds a chart configuration object. Think of it like a blueprint for the chart. It specifies the type of the chart, here in this case a bar chart, and details like colors, borders, labels. It even sets chart options like whether the y-axis should start at 0 or where it should appear. So from a bunch of raw JSON records, you get a perfectly structured chart config ready to be turned into a visual image. Okay, so that, or you can say the configuration object for the chart to be created in the next step. Okay, now next comes the default config chart. Okay, so in the default config chart, this node takes that structured chart config that we created in the previous node and the raw data and performs a little more magic. This is where the workflow adds sophistication to the process. Okay, first it checks if there is any actual data. Okay, maybe your query returned nothing, 0 records. Instead of failing or sending an empty chart, it creates a default chart config that says no data available, which is much more friendlier than for the end users. But if there is a data, it takes the raw data and tries to generate more meaningful labels. This is handy when your raw data has multiple fields, or say product name plus warehouse name. The code builds labels that combine these details like widget A, making the chart more informative. It also extracts the numeric values carefully, looking across several possible fields such as quantity, amount, or total stock, wherever the meaningful number lives. This makes the workflow adaptable to different kind of data sources without needing to rewrite the whole thing. Then it assembles the final chart configuration object again with enhanced options. For instance, it integrates a plugin that displays the exact numbers on the top of the bars in the chart, making it easier to read. It even sets label colors and the fonts, so your chart looks polished and professional. Finally, this notes prepares the data to be sent to the chart rendering service. Now let's talk about the chart rendering. This is handled by the generate chart via QuickChart a node. It uses an external API called QuickChart, which lets you send the chart config as JSON and returns a PNG image of the chart. Why is this important? Because rendering charts programmatically inside many low-code or no-code tools is very tricky. Using a service like QuickChart offloads the rendering to a specialized engine, freeing you from having to install or maintain any chart libraries within n8n itself. In this node, the workflow sends a post request to QuickChart's API, including the JSON chart config, the desired image size, and the format, right? The header ensures it is interpreted as JSON. Then the QuickChart returns a URL or the image itself that you can use anywhere. You can embed it on a website, attach it to an email, or display it on a dashboard. Okay. So now after this node, once the chart is generated, whether it is a bar chart or a pie chart or any kind of other charts, right? When that gets generated, then comes the next node. Not the next node, but I wanted to cover this handle no results, because we talked about check if query results exist in the previous nodes, right? So there are two paths. One is the happy path, which is true. When it's true, it goes through format data for visualization, then default chart config, and then rendering of the chart that we already just talked about, right? But the not so happy path is when it's false. If the query results do not exist, then there is a here to handle no results, right? It will give a message that no data was returned from your query. Please try rephrasing your questions or check if the requested data exists in the database, right? So it's a simple code snippet that catches empty responses and returns a standardized JSON object. It sets a success flag to false, includes a friendly message like no data found for your query. Finally comes the merge node. So we'll talk about now the merge node. Then comes the Google Drive node. Let's zoom in on this part. In n8n, we use something called the Google Drive node. This is where the magic of uploading happens. So here is how it works. First, you choose your Google Drive account, okay, in the node's credentials. Then you set the file name. In our case, we are dynamically setting the name using a neat trick. We use the chart title that we defined earlier in the data, like monthly sales report or a top performing products, and make it as a title. Then we set the destination folder. If you don't specify anything, it goes to the root folder. But if you can direct it to the subfolder, it's definitely better. We also pass in the actual image file from the QuickChart. Once this node runs, your chart is uploaded to the Google Drive, right, as a real file, ready to view or download. And here is the best part. This node gives us back some really useful links. First one is web content link. That is a direct download link to the image. Second one is the web view link. This lets you open the chart in your browser in Google Drive. And third one is thumbnail link. This is a small preview image of a chart, right? And these links, we are going to use them in our next step. So let's go to the next step, which is the merge node, right? So you can think of merge node as something like a glue that binds multiple pieces of data together. Let me explain. By the time we have reached this point, we have two different sets of data in the workflow. One set comes from the earlier node that we just talked about. This includes stuff like the formatted insights, the number of records we processed, or maybe there was no result that was found, right? So no result found message, right? Other one is from the Google Drive node, which include those important links we just talked about. But n8n does not automatically know how to combine these. So we have to use something called a merge node. We connect both data flows, the inside data and the Google Drive data, and we merge them into this node. So here we are using append to merge them. Okay. So we are simply combining the inputs, taking the two pieces of JSON and sticking them together into one nice structured objects. This gives the final node everything it needs in one place. So now we come to the most polished part of our workflow, for which we are all waiting for, the final response node. This is where we take everything, all the process data, whatever we have worked so far, wrap it into a nice readable message and prepare it to be shown, sent to the user however you like. Let me walk you through what happens inside this one. We are using this an n8n code node which lets us write custom JavaScript. So this is a custom JavaScript which basically takes the inputs from the previous node that we just went through, right? And then it kind of creates, it takes the combined data, right? And then it pulls out the information that we need. This includes the chart links, the insights and metadata, and then creates the final output. So that is the beauty of n8n. You can go through multiple automation steps, you can customize it, and then finally whatever data that you need in whatever format, you can generate it, and there are n number of nodes using which you can generate it. So let's come to, so once we have created the final response, it can be fed back to the users either through in the chatbot message, or it can be posted to Slack or Google Sheet. However user wants to access the data, this can be done. So, right, but there are other real world examples where you can configure or customize this workflow to behave in a different way. Say you are running a marketing campaign across multiple platforms like Google Ads, Facebook, LinkedIn. You've got a bunch of data about impressions, clicks and conversions, right? So you can actually pull in those data through API, use a code node to calculate things like click-through rates, cost per acquisitions and return on investment, and you can use QuickChart to visualize performance across multiple platforms. Upload that chart to Google Drive folder so that this can be seen by the customer or the end user, and create a response message showing key insights plus a link to view or download the chart. Now every day or even every hour, your team can get an automated visual report, no manual download, no screenshots. So now you have a fully automated, beautifully designed workflow that saves you hours of manual work and delivers polished professional results every single time. Whether you are a solo creator, a data analyst, or running report for clients, this setup can seriously level up your game. Before you go, if you want to try this exact workflow for yourself, I've got something for you. I have patched up the full n8n workflow complete with all the nodes, sample data and a quick chart templates, and you can download it right now using the link in the description below. Just import it into your n8n instance, update your credentials, and you're ready to roll in minutes. Don't forget to grab that link. It will save you a ton of time and give you a solid foundation to build on. If you found this helpful, please give this video a thumbs up, share it with your friends, hit that subscribe button for more automation tutorials just like this one. Thanks for watching, and until next time, keep building, keep automating, and take care. Thank you.